Hi all, I am Suchithra, working as an assistant professor in the Department of Artificial Intelligence and Data Science in SNS College of Engineering. In this video, we are going to see about the topic problem formulation in problem solving and C programming. First, we will see what is problem formation. First, we need to identify a problem, then we need to problem selection, then problem definition. These will come under the criteria for problem selection. Algorithmic problem solving. Algorithmic problem solving, this means solving problem that require the formulation of an algorithm for their solution. The formation of algorithm has always been an important element of problem solving. Why we need to for algorithm to solve problem? A computer is a tool that can be used to implement a plan for solving problem. A computer program is a set of instructions for a computer. These instructions describe the steps that the computer must follow to implement a plan. An algorithm is a plan for solving problem. A person must design an algorithm. A person must translate an algorithm into a computer program. Algorithmic development process. Every problem solution starts with a plan. That plan is called as algorithm. An algorithm is a plan for solving problem. There are many ways to write an algorithm. First one is some are very informal, some are quite formal, mathematical in nature, some are quite graphical. Once we have an algorithm, we can translate into a computer program in some programming language. Our algorithm development process consists of 5 major steps. The first step is obtain a description of the problem. Second step is analyze the problem. Third step is develop a high level algorithm. Fourth one is refine the algorithm by adding model detail. Fifth one is review the algorithm. First step, obtain the description of a problem. The step much more difficult than it appears. In the following discussion, the word client refers to someone who wants to find a solution to the problem. The word developer refers to a person, someone who finds a way to solve the problem. The developer must create an algorithm that will solve the client's problem. Second step, analyze the problem. The purpose of this step is to determine both the starting and ending point for solving the problem. This process is analogous to a mathematician determining what is given and what must be proven. A good problem description must make it easy to perform these steps. When determining the starting point, we should start by seeking answer to the following questions. What data are available? Where is the data? What formulas pertain to the problem? What rules exist for working with the data? What relationship exists among the data values? When determining the ending point, we need to describe the characteristics of the solution. In other words, how will we know when we are done? Asking the following questions often help to determine the ending point. What new fact will we have? What item will we change? What changes will be made to those items? What things will no longer exist? Step 3. Develop a high-level algorithm. An algorithm is a plan for solving a problem, but plans comes in several levels of detail. It usually better to start with a high-level algorithm that includes the major part of solution. The problem, I need a same-day birthday card to my brother Mark. Analysis, I don't have a card. I prefer to buy a card rather than make one myself. High-level algorithm. Go to the store that sells greeting card, select a card, purchase a card, mail the card. Fourth step, refine the algorithm by adding more details. Stepwise refinement is a process for developing a detailed algorithm by gradually adding detail to the high-level algorithms. The previous algorithm is satisfactory for daily use, but it lacks detail that would have to be added by the computer to carry out the solution. These details include answer to the questions such as following. Which store will I visit? How will I get there? Walk, drive, ride my bicycle, take the bus. What kind of car does Mark like? Humorous, sentimental, risky, etc. Step 5. Review the algorithm. Need to work through the algorithm step by step to determine whether or not it will solve the original problem. The following questions are typically of ones that should be asked whenever we review the algorithm. First one. Does this algorithm solve very specific problem or does it solve a more generic problem? If it is solve a very specific problem, should it be generalized? Can this algorithm be simplified? Is the solution similar to the solution to another problem? How are they differ?